So, I know when I want to take the derivative of this expression, I have to take the derivative of both sides. So the derivative of this side, this 3x squared plus 2y cubed all to the second power. And I'm also going to have to take the derivative of this other side, this derivative of 5. Don't forget both sides, okay? Some people sometimes will forget that one. I've been known to forget that as well. Okay. So when you're looking at the derivative of the left side, what's the outermost function here? The 2. Okay, so let's take care of that first. 2 blank 1, right? Taking care of that 2. What about the inside? What do? Leave it alone. 3x squared plus 2y cubed. Multiply. Now we have to take the derivative of the inside, right? What's the derivative of 3x squared? Now remember that when you take the derivative, you're going to get a binomial here, right? So you're going to need parentheses. So this is going to be 6x. And what's the derivative of 2y cubed? 6y squared times dy dx. Then over here, what's the derivative of 5? 0. Okay. Now, since all these things have power 1, we're gonna multiply them together. So I'm gonna start with this. This is gonna be 6x squared plus 4y cubed multiplied by 6x plus 6y squared dy dx is equal to 0. And then I'm gonna FOIL it. So first is gonna be 36x cubed. Outside is gonna be plus 36x squared y squared dy dx. Inside's going to be plus 24xy cubed, and then last is going to be plus 24y to the 5th dy dx, and this is equal to 0. Does that make sense? That I'm just expanding completely? So when you have something that's in this form with a bunch of parentheses, it's hard to solve for anything. So what you want to always do is the most powerful form, or the easiest form of the equation, is just something plus something plus something plus something. Does that make sense? Because then you can send things to the other side by simply changing their signs. So the things that get to stay on the left are the dy dx's, those terms. The ones on the right are going to be the ones without it. So 36x squared y squared dy dx is going to stay on the left. The 24y to the 5th dy dx is going to stay on the left. And anything without a dy dx, like this, is going to have to go over, and this is going to have to go over as well. So they're going to change signs when you send them to the right. So minus 36x cubed minus 24xy cubed. Now everything has a dy dx in it. So what can you factor out? The dy dx. So if I factor out a dy dx, you're going to have 36x squared y squared plus 24y cubed is equal to the same right side, right? Is equal to the same right side. And what are you going to do with this in order to get rid of it? Divide. So dy dx is going to be equal to this negative 36x cubed minus 24xy cubed all over 36x squared y squared plus 24y cubed. And yeah, nothing cancels. I don't share anything. So I think you guys probably got the derivative right. I'm pretty sure you probably feel pretty comfortable with that, or at least got it close. Knowing that you have to put that in parentheses is something that's kind of a star for me to make sure to mention. And then expanding completely. Let's do another one. So B was y squared equals x squared plus the sine of xy. Now this, it looks rather tame until you start taking the derivative. And it's because of that product rule that makes it a little messy, okay? So let's take the derivative of everything. So derivative with respect to x of both sides. All right, so the derivative of y squared. 2y dy dx equals the derivative of x squared. 2x. The derivative of the sine is something. Cosine of that something, right? You leave the inside alone. multiplied by the derivative of what's inside, right? Now what's inside is a what? It's a product, so you're going to need and the product rule is a binomial, right? F prime g plus f g prime, so it means I'm going to have some parentheses here. Okay. So derivative of the first, 1 times the second, plus the first, times the derivative of the second, 1 times dy dx. Does that make sense? Okay, now we still have to, I have to get rid of parentheses, so I'm going to have to multiply those two factors together, right? So these are just going to become the coefficients of the cosine, okay? I'm going to put them in front. I like the trig functions to go at the very end of a term, okay? So I'm going to have 2y dy dx equals 2x plus, so when I multiply these together, I'm going to have y cosine of xy. And when I multiply this into this, I'm going to have x dy dx cosine of xy. I like to stay away from the argument, so I don't like to put this y behind it, because if the notation isn't perfect, you might think that y goes in here and that would be xy squared when it's not, right? Can I multiply these things together, this y and the xy? Why not? What's stopping me? The cosine function's blocking, right? Because you have to do the cosine before you do this, right? You have to take care of all parentheses before you take care of multiplication. So it doesn't simplify. All right, so that means anything with a dy dx is going to go on the left, and anything without a dy dx is going to stay on the right. So that means this term's got to go to the other side. So 2x dy dx minus x dy dx cosine of xy is going to be equal to 2x plus y cosine of xy. Now, since everything over here has a dy dx in it, I can pull it out. You guys agree this has that, remember solving for inverses? It's got that feel to it. Yeah, so it's why we practiced it so much, because it's a very common solving technique, and especially later in math. So then we're going to divide by this piece right here. So 2x plus y cosine of xy all over 2y minus x cosine xy. Oh, I got a question. Do those cosine xy's cancel? No, because if you cancel a cosine xy, you got to do it from everything, right? I have 1, 2, 3, 4 terms there, right? So if you cancel from one, you got to cancel from everything, right? You can't just selectively do it. And that's it. That's our nice, pretty answer. So the derivatives in this section look kind of messy. I got a question. How would you what if I wanted to take the derivative again? We're not going to, because this is far too messy. What if I wanted to take the second derivative? Yeah, just derivative of this again. You guys agree? Does that make sense? Okay. So it's just a derivative of the derivative. You guys want to? It's getting nasty. You guys want to go?